So we're going to continue conic sections, and in this video I'm going to talk about the ellipse. So again, you can see here when the plane cuts the cone at an angle, we form an ellipse. Now with both parabola and ellipse, the plane is cutting the cone at an angle, but you can see how the angle is different for the ellipse and different for the parabola. Now, how we draw an ellipse, I want you to just click on this link and watch this like 2-minute YouTube video, which is really pretty cool. So the ellipse is a curve formed by the intersection of a plane and a double cone such that the plane cuts the cone at an angle, right? So it's kind of cutting it in this angle, and that's how you're getting the ellipse. So a typical example of ellipse is when you will see that an egg is like an ellipse shape, or even when we draw for planetary motion, we draw an ellipse, right? So planetary motions take that elliptical path. Now, again, coming back to the definition using the locus, right? For every one of the conic sections, we can do that. So for ellipse, it is a set of all points x, y in a plane, the sum of whose distances from two distinct fixed points is constant. Okay, so what does that mean? So let us look at the ellipse here. So it's, if you take a point x, y, okay, and you have two focal points here. In the other ones we had one focal point, here you have two focal points, and sometimes plural of focus is foci. Okay, so you will see that F-O-C-I, okay, foci. So if you take this point xy and then you calculate the distance to one foci and then the distance to the second foci, and you add them up, that is always the same for every point. So what does that mean? This is xy, but suppose I'm going to take a point here, which is x1, y1. I do the same thing. I draw a line from there to this foci, and I draw a line from there to this foci, and I'm going to call that D3, D4. Now, if you were to add the distance of D3 and D4, it's going to be the same as D1 and D2. So a collection of such points makes up your ellipse. Okay, so again, just to be clear, I'm going to take another point and then I'm going to draw a line to one focus and a line to another focus, and let's call that distance D5 and D6. Now again, if I were to add D5 and D6, it's going to be the same as D3 plus D4 and D1 plus D2. So a collection of such points makes up your ellipse. Now in ellipse, you have quite a bit of vocabulary. Again, this is the center. Okay, so here the center is the origin, but it's not necessarily should be the origin, it can be h, k. Now you have you can see how the ellipse is elongated. It's elongated on one side, right? So that means it's longer on one side and shorter on the other side. Now the longer side is called the major axis, and the shorter side is called the minor axis. Okay, now where the major axis touches the ellipse at the extremities, those points are called the vertices. Okay, so major axis, you have vertices, and for the minor axis, where it touches the extremities, where this minor axis touches the extremities, they are called co-vertices. So the major axis where it touches the extreme end of the ellipses is vertices, and for the minor axis it is co-vertices. So first of all, this big one, because it's long is called the major axis, and this one is short, so it's called the minor axis. And then we talked about focus, and then we have the center. So these are all kind of the important parts of an ellipse, so you can say. And let's go down further. Now you can have ellipse in where the major axis is along the x-axis like we just saw, or the major axis can be along the y-axis. So here if it's along the x-axis, it's called a horizontal ellipse, and if it's along the y-axis, it's called a vertical ellipse. Okay, now what about the equations for these, right? So let's write down the equations for them. The standard form, let's take care of the horizontal ellipse first. So it's x square by a square plus y square by b square is equal to 1, and your a is greater than b. In the vertical ellipse, the a, b gets switched. So you have x square over b square plus y square over a square is equal to 1. And same thing, your a is greater than b. The way to remember this is the horizontal ellipse is like a dining table, whereas the vertical ellipse is like a mirror. Okay, that's kind of a quick way to remember it. Now there is also a relationship between the vertices, the co-vertices, and the foci. Okay, and what is that relationship? Now a good way to derive this relationship is, let's look at the ellipse once again. So along the major axis you have your vertices, and along the minor axis you have your co-vertices, and then you have your two foci here. Okay, f1, f2 or f dash. Now we said that this distance, right, from any point on the ellipse, if we take the distance of the two foci and add them up, it should be the same. So from 0b, my distance is what? D1 and D2. So when I add D1 and D2, it should be the same as from this point, right? From A0. What would it be from here to here? This distance. And then from here to here, this distance. So this was D3, D4, your D3 and D4, when you sum it up, it should be the same as D1 plus D2. So let's do some little proof here. First of all, let's remember the distance formula. If you have 2 points x1, y1 and x2, y2, this is your distance formula. right? Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So we're going to use that distance formula. So what distances do we need to calculate? We need to calculate between this focus and 0b and this focus and 0b. So let's do that first, right? So it's minus c0b and c0, 0b. If I calculate the distance, I get, with a little bit of algebra, this is what I get, right? So that distance, the sum of that distance is 2 times square root of c square plus b square. Now we're going to calculate the distance from A0 to both the foci. Again, it's minus C0 and A0 and C0 and A0. So you'll do a little bit of distance formula and you're going to get 2A. Now these two distances have to be equal, right? That is how an ellipse is defined. So that means that 2A is equal to this. Again, a little bit of algebra. You can take out the common factor and then you square both sides, right? You end up getting this. So this is the relationship between foci, vertices and co-vertices, and we're going to use this a lot. So it is like Pythagoras theorem, but actually it is subtraction, not addition. Okay, all right. What kind of problems are you going to get? So let's look at that. Like problem number 35 in the book is find the center and vertices of the ellipse and sketch its graph. So they gave you this, right? And they want you to calculate the center and the vertices and they want you to sketch the graph. Okay, so now you have to, when you're sketching these graphs, the important thing is to find out first which one is the major axis, right? Is x-axis the major axis or the y-axis the major axis? So the way you do that is you look at a square and b square. So you know that a has to be bigger than b. So 25 is bigger than 16, right? So you know that this one, the major axis is going to be the x-axis. Always, whichever variable's denominator is bigger, so whichever variable's denominator is bigger, that is your major axis. So here a square was bigger, so therefore x is your major axis. Okay, so this is the kind of like so whichever denominator is bigger, that's your major axis. Okay, so now you know that. So if it's a major axis, that means it's the coordinates of the vertices, right? So the coordinates of the vertices are this, plus minus 5, 0. Now, so then what happens to the co-vertices? It's the other one, right? The 16. So 0, plus minus b. So now your co-vertices become 0 and plus minus 4. And how am I getting the 4? Square root of 16, right? B square is 16, so b is plus minus 4. Here a square is 25, so a is plus minus 4. Now we have the relationship between vertices, co-vertices and foci, right? So you can use that and calculate the foci, plus minus 3, 0. Now you're ready to graph. You have all the points, right? And so you're going to put the vertices here first. 5, 0, 5, 0, minus 5, 0. You're going to put the co-vertices 0, 4, 0, minus 4. Then you have the foci. Now you're ready to graph. You know it's the major axis is here, so you know that this is going to be it's elongated on your x-axis, So therefore, the way you do it is it's not quite a ellipse, but you get my point. We have to just do our best here for okay. Yeah. Anyway, so that is how you write out everything, and then you finally eventually draw your ellipse. Okay. What's another kind of question? Similar. We're just going to see that the major axis is going to be different now. So that's why I wanted to show this one. It's x square by 28 plus y square by 64. So your a square is 64 and b square is 28. So which one's denominator is bigger? The y's denominator is bigger, right? So therefore your major axis is now the y-axis. So your whichever is the major axis, that's the vertices, right? So the vertices become plus and minus 8 and the co-vertices become plus and minus 2 root 7. How did I get 2 root 7? Because b square is 28, right? Your b square is 28. So b is square root of 28 and we can write this as 7 times 4 or 2 root 7. That's how I got that. And then you use the relationship of c square is equal to a square minus b square to get the foci. And then same thing again. You write out, you have a graph, you put all the important points. So now this is your vertices. This is your co-vertices. And then this is focus 1. Focus 2. So now your ellipse is going to be something like this, right? It's elongated on the y. So that's your ellipse. The second kind of question you might get is where you are said that you're just given the foci and the vertices and you have to find the equation of the ellipse. Okay, so if the foci is, so again I'm going to do a rough sketch first where I know my vertices are plus minus 5, so I write that out, plus minus 5, right? And then my vertices, which is in the wrong position here, let's fix that. Okay. Plus minus 2, 0. So here are my vertices, right? 2, 0, minus 2, 0. And I use the c square is equal to a square minus b square and find out that b square is 21. And I know that your a square is greater than b square, so therefore your x-axis is your major axis, right? And so now the equation just becomes x square by 25 plus y square by 21 is equal to 1. That is, I'm using x square by a square plus y square by b square is equal to 1, where a is greater than b. So another example where here you got the vertices to be 0, plus minus 8 and the foci is 0, plus minus 4. Again, I'm going to do a rough sketch, right? So I know that here is my 2 vertices, here are my foci. So I know that this is going to be my major axis. So therefore, I'm going to get my b square is 48 and sure enough, a square is greater than b square. And so your major axis is your y-axis, right? So therefore the equation is going to be the a and the b get switched. So x square by 48 plus y square by 64 is equal to 1. So your ellipse is going to be something like this, right? It's on the long side. The other kind of problem you can get is where you're given the foci and given that the length of the major axis is 12 units. So if the length of the major axis is nothing but 2a, because why? Where am I getting this 2a from? Let's go back all the way to this picture here, right? So we said this is your major axis and here's a0 minus a0. So what is the length of this? So from here to here is a, here to here is another a, therefore 2a, right? So your major axis length is 2a and minor axis length is 2b. So that's where I got the 2a from. Now coming back to the problem again. So 2a is 12, which means a is 6 or a square is 36. You know your c square is 25 because they gave you the foci. Then you use the c square is equal to a square minus b square and get b square. And so therefore, this is your answer. Okay. So these are kind of the problems you're going to get for ellipse. And I will see you in the next video where I talk about the hyperbola.